Okay, so this is just going to be a real quick introduction video on thermodynamics. So one of the first things I wanted to do is just kind of define what thermodynamics is. And you can think of this as just a branch of science that deals with the relationships between heat and other forms of energy. So before we get too far into like calculations or anything like that in future videos, we're going to define quite a few terms on this video. So we know that this is we're dealing with heat and forms of energy in this particular branch of science. So we'll need to talk a little bit about energy. Now, what we're going to be dealing with here is basically two different definitions. The second one is going to be the one we're going to be more concerned with in this particular unit of instruction. But energy can be thought of as the ability to do work or transfer heat. So you could think of energy as energy being used to cause an object that has mass to move. In that case, it'd be called work. Or energy can be used to cause the temperature of an object to rise. If you're using energy to change the temperature of an object, you're going to refer to that energy as heat. And we're going to be looking a lot at heat transfer in this particular unit. And there's several different definitions we'll need to cover. So two terms that are going to be used a lot in thermodynamics is the system and the surroundings. And what's unique about these two terms is when you encase something in these two terms, so system and surroundings, you're actually talking about the entire universe, which is kind of interesting to take the whole universe and limit it to two different terms. The system is going to be what you are studying. So it's in thermochemistry, if you're going in the chemistry realm and you're studying thermodynamics, you're going to be talking about molecules or atoms. And the surroundings is going to be everything else in the universe. So if you're studying a collection of hydrogen molecules, that would be your system. And every other atom in the universe would be your surroundings. So the easy way to remember this is the system is whatever you're studying in the problem or whatever you're analyzing. And every single thing left over, the entire rest of the universe, is going to be counted as the surroundings. Now on this diagram, what we've got here are some different molecules here in this cylinder. So these molecules that are being studied, they are going to be classified as the system. And the cylinder, the piston, which is what this diagram is representing, and everything else is the surroundings. So, some other key things to know. Energy can also be transferred as heat, and heat will always flow from warmer objects to cooler objects, and that's going to be pretty important. So this right here is going to be a real key concept because we're going to be looking at a lot of calculations that involve heat flow. So just remember that heat will always flow from something warmer to something colder. That brings us to a really important scientific law. And that's going to be the first law of thermodynamics. So the first law of thermodynamics talks about energy conservation, and it states that energy can neither be created nor destroyed. So in other words, the total amount of energy in the universe is a constant. If the system loses energy, then it must be gained by the surroundings, or vice versa. So we kind of talked about how the universe in thermodynamics can be broken down into two parts. So the entire universe is either the system, what you're studying, and then everything else, which is known as the surroundings. So, for example, if you had a, let's say a cube of some kind of metal, and let's say you had a glass or a cup full of water. If you drop this metal into the water, and the metal is hotter than the water, then that hot metal is going to transfer its heat to the water and the rest of the surroundings. So if you're studying the metal, then your system would be the atoms and molecules that make up the metal, or the atoms that make up the metal. And everything else is going to be your surroundings. So if the metal again is warmer than the water, you drop the metal in room temperature water, it's hot metal, then the heat from the metal will transfer to the water and raise the temperature of the water. And those are some of the kind of calculations that will be happening down the road. So with heat flow, there's a couple ways to define it. And there's two key terms when you talk about heat exchange. One of those terms is called endothermic, and the other term is called exothermic. Whenever heat is absorbed by the system from the surroundings, it's known as endothermic. However, whenever the heat is released by the system into the surroundings, this is known as an exothermic process. So whatever you're studying, if heat's going into that particular thing you're studying, it's endothermic. And if heat is ever being released by the thing you're studying, the atoms or molecules you're studying, then it's known as exothermic. So one way I kind of remember this is you take kind of the viewpoint of the system. So if it's going into the system, it's endo. If it's going out of the system, it's exo. There are some, basically here what I have here is a list of different common examples between the two. So these are just some common ones that you might encounter. Probably the most common of them all would probably be melting and freezing. So endothermic, if you have something and it needs to melt, it's going to have to absorb heat. So let's say that the H2O molecules in ice are going to be your system. If you're trying to melt that ice, changing it from a solid to a liquid, then you're going to need heat to do that. So the ice cube is going to have to absorb heat from its surroundings. So it's going to be classified as endothermic. Now, if you are wanting to freeze something, so let's say you've got liquid water, you're going to need to lose some of your heat. So the water is going to need to lose energy. So if the water transfers its energy to the surroundings, then it will become colder. So it's all about which way the heat flow is going. So there's several different examples on here, but these are just some things to look at. In the next few videos, we're going to be looking a lot at some mathematics and how some calculations come into play here.